Okay, well, it seems to be the official time, at least my laptop thinks so. So let us go ahead and begin. Does anybody does anybody have any questions about anything from past weeks before we dive into today's stuff? I was asked about whether there's a quiz today. There's a quiz on Thursday this week because of my being a little bit behind schedule. So the quiz that normally would have been at the end of today will be at the end of Thursday instead. Yeah, today's Tuesday, right? So Thursday, yes. And it will cover material from weeks 2 and 3. Okay? Oh, you can't see my... Oh. I seem to have to plug in to get you to be able to see stuff. There we go. All right. So we've introduced 5 different data types that contain other things. So a str contains a sequence of 1-character substrings. A list can contain a list of any kinds of things. Tuples can contain any kinds of things. Sets and dicts are a little more restricted. Sets can only contain so-called hashable things, such as fundamental data type objects, or tuples that only contain so-called hashable items. And dictionaries, likewise, the keys are restricted to being unique hashable values. It can feel a bit like swimming in a sea of things that are kind of the same and kind of different. So what I'd like to do today is to sort of go through all 5 of these in a very systematic way to do comparing and contrasting of them. And hopefully this will clarify your understanding a little bit. And if you do have any questions, it'll give you a chance to ask. So we're going to take a look at how to create these things, how to access and modify these things, how to delete them, and also how to convert back and forth among them. And please fire away with questions whenever you have them. All right, now, so the basic approach to programming that we're working on in here with relatively small programs is to get some data from somewhere, process that data in some fashion, and then produce some output that's of use to someone. And it dawned on me in the elevator today on the way down from my office that a lot of what you do with processing data is you start with raw data that's just in whatever form that you get it. And the first thing you do with that is to throw away the parts of the data that you don't want. Okay, like we were reading in lines from a file, and we were throwing away the new lines because we didn't want those to continue processing the file. And this is, I don't think I had really consciously thought of it this way before, but this is how I tend to approach real problems. When I'm faced with some monstrous, god-awful data set that's in some nasty format, the first thing I think about is, well, what's the easiest stuff to throw away that I don't want? And then what's the next easiest stuff to throw away? And then what's the next easiest stuff to throw away? Until eventually you have left the data that you want, and you've eliminated all of the data that you don't want. And then you can start forming that data that you have left into lists or dictionaries or sets or whatever makes sense. Okay? So think of, you're getting this data with nasty stuff in it that you don't want, and throw stuff away, throw stuff away, throw stuff away is kind of the first part of your processing. All right, so we typically have a lot of data to keep track of, and we need to consider which of these various so-called containers to put that data in. Strings are pretty straightforward. If we want to keep track of a sequence of characters, then a string is designed for that. If we want to keep track of values in some specific order, like the order that we read them in, then a list is an appropriate kind of data structure to use for that. We read the first piece of information, we make that the first item in a list. We read another piece of information, append that to the list, another piece, append that to the list, and so on. We could also use a tuple for that purpose if we wanted to be careful that we didn't accidentally change the item stored in the tuple. But in real life, the only difference between lists and tuples is that you can change items in lists. You can't directly change items in tuples. But it's so easy to just create new tuples containing stuff that used to be in the old tuple that I don't know realistically how much difference there actually is. Now, the value of a set, the benefit of a set, is that it can only contain one copy of each of the values that you put in it. So if you have information about a bunch of customers, like sales records for a whole bunch of customers, each record that you read in has a customer name and a date and a dollar amount and perhaps some description of what it is that they bought. And you can read that in, and you can build your set of customers by just adding, start with an empty set of customers and add a customer, add a customer, add a customer, add a customer. When you're done, the set will contain exactly one copy of all of the customers from your data. And it's just the nature of how a set works that you don't have to worry about whether those you don't have to worry about whether you're adding something that you've already added, because the set will take care of that. It will make sure that you only have exactly one copy of each one. Then a dictionary. Now, what's a list? Well, a list is a sequence of values with integer subscripts, right? We have the item sub 0, the item sub 1, the item sub 2, the item sub 3. If you think about it, a dict is really kind of the same thing, except that instead of integer subscripts to look up values, we have arbitrary keys that we use to look up values. So you can use a list if you can think of the items that you're trying to store just as sequential items, 0, 1, 2, 3. A dict is the same kind of idea, but in this case, the subscripts are not just sequential integers. They can be strings, they can be floats, they can be integers, and so forth. And so a dict gives you a mapping or an association from some arbitrary kind of key into some associated value. Now, I said arbitrary there, but there is a restriction. The keys do have to be hashable. So you can't use a list as a key. You can't use a set as a key. You can't use a dict as a key. All right. Any questions come up so far from any of that? Yes? Okay, excellent. So what is a hashable value? It's easiest to talk about hashable values if I talk about having two different values. Hashable values are values that can be told apart from each other, and that have a unique value associated with them. So, for example, the value 0. There's only one of those, okay? You can tell it apart from 1. You can tell it apart from hello. You can tell it apart from 7.7. So that int value 0 is a so-called hashable item. And not only can you tell it apart from strings and floats and whatever else I said, but you can tell it apart from other int values as well. So you can tell 0 apart from 1, you can tell 1 apart from 2, and so on. So it's a unique value that you can easily tell apart from other values. Two different hashable objects, if you ask whether they are equal to each other with the double equal sign, that will be false. Okay? Someone had a question in the back? Yeah.
Boolean values, if I say something is true and something
Excellent question. No, Boolean values are hashable, but there's only one true and there's only one false. Now, many variables can refer to true and many other variables can refer to false, but there's only one object in your environment named true and there's only one object named false. And you can tell them apart. You know, if you ask whether true is equal to false, you get told that's false. Okay. Now, for the built-in data types, for the lowest level data types, all of those things are hashable. So ints are hashable, floats are hashable, strs are hashable, bools are hashable, and the sole value none is also hashable. You can compare all of those things to each other, and unless the values are identical, they will, well, not only are the okay. Actually, I said the equal test. It's actually, correctly speaking, it's actually the is test. If you compare whether one object is another object and get false, that means that they are different objects. The reason that we talk about things being hashable as opposed to things just being these low-level data types is that it is possible to create higher-level data types, including user-defined data types, so-called classes, to which you can add a hash function that will compute a unique hash value for each item in your user-defined class. So I could set up, like, let's say a class called employee or a class called student, where every student has a name, a university Andrew ID, and so on. And if I compare two students to ask whether, you know, is Bill, or, you know, Bill is John, that's going to be false. For that to be hashable, I would have to actually define a hashing function for the student class that I created. That's not something that's built into the language the way it's built in for things like ints and floats and strs and so forth. Was that sort of helpful? More to your question? Was that helpful, or? Okay, all right. I don't have my glasses on, so you have to nod vigorously for me to be able to see. All right. So let's move on and talk about creating, accessing, modifying, destroying, and converting all of these different things. Okay. Now, in a program, most of the input that you get, whether you read it from a file or get it from a user, is going to arrive as a str object. And also, when you eventually create output, sorry, let me get my pen turned on there. When eventually you create output, you have to turn things back into strs again, so that the user can read some, you know, meaningful result from your program. We take these str objects that we get as input, and we do various kinds of stripping, splitting, converting strings into floats or ints or bools or what have you, so that we then can do things like arithmetic and relational comparisons and logic and so forth. Okay, so it's sort of this middle part that we're going to be talking about here. Here's simply a table that shows examples of how to create these 5 different collection or container types. And most of them are pretty straightforward. There's a couple of little strange warts in here. If you want to create an empty string, One easy way to do that is to just use a pair of single quotes next to each other, or double quotes, or triple single quotes, or triple double quotes. Any of those mechanisms will create an empty string for you. It turns out you can also use the conversion function and just leave out any argument. So if you say stir open and close paren, that is yet another way of creating an empty string. To create a string with one item, that's easy. You just put one item between the quotes. I should say one recognized human readable symbol between the quotes. And for multiple items, you just put multiple items in. A list, to create an empty one, you use square brackets. A tuple, use parentheses. For a dictionary, you use the curly braces, and here's one of the little warts that I was mentioning that it's very important to remember, which is that curly braces are also used when you create sets and when you interact with sets and when you display sets. But to create an empty one, you have to use the conversion function without any arguments. Okay, so you need to say set open close paren in order to get an empty set. I was going to say there is no other way to do it, and every time I say there is no way or this always happens or something like that, I immediately start thinking, well, there must be some other way. Well, yeah, you could do something stupid like starting with a set that had stuff in it and clearing it, and that would give you an empty set. But I can't think of any other direct way of creating a brand new empty set. Okay, now for one items, again, these are kind of straightforward, with the exception of a one-item tuple. Here's the other sort of peculiar wart or strangeness. If you want to create a tuple that has one item in it, you can't just use the parentheses, because the parentheses also mean to just contain some kind of arithmetic expression or some kind of logical expression. Okay, so the parentheses also are used for calling a function. So the parentheses, it turns out, has multiple meanings in the language, and you have to keep straight which meaning is being used in this current context. Okay, here, if I just said parenthesis 1 parenthesis, well, that would just be an arithmetic expression inside of parenthesis, and it would be equal to the value 1, right? So I have to say parenthesis 1 comma close parenthesis to create a tuple that just has one argument in it. Okay, and these other things are pretty straightforward. Everybody happy with creating things? Okay. Now, all of these different collection types have certain attributes that you just have to know. And they're not hard. You just have to, you just have to know them. The stir and the tuple are immutable. That is, you cannot say something like S gets hello, and then say S sub 2 gets an X. That's not allowed. Similarly for a tuple. But the other data types, list, set, and dict, are mutable. You can not only add items to a list or a set or a dict, but you can also modify existing items within these things. Okay, so if I have a list, I can, of course, if I can type, I can say M sub 0 gets hello, and that works fine. All of these collection types are iterable, okay? You can use all of these things and step through what they contain using a for loop. Or you can use them in conversion functions to construct these things from each other because they're all iterable. Now, the dictionary is unusual in that you have a choice of iterables. Let me just create a trivial dictionary here. D is let's have the key A associated with 123 and the key B associated with high, and the string, well, I don't even have to have strings that are all the same data type, so I'm going to have the string 7 associated with true. D itself is an iterable. By default, the iterable is on keys, right? So if I say for x in D, print D, I'm going to get you see what I did? For each key in the dictionary, I printed the whole dictionary. Oops, not what I had in mind. For x in D, print x is what I had in mind. And so that prints out the keys that are in D. If you want to be more explicit about getting the keys, then you can say d.keys. And if you would rather get the values, you can say d.values. And the values will be displayed in the same order that the keys are displayed in. Starting officially in the current version of Python, that is Python 3.7, when you add key value pairs to a dictionary, they're stored in the dictionary in the same order that you added them. In older versions of Python, they were just stored in some arbitrary order, the way items in a set are stored in some arbitrary order. But apparently people didn't like that, and a bunch of people complained, and so in the current version, the items in the dictionary are stored in key creation order. You can see items from the dictionary with d.items, and, whoops, I forgot my in, for x in d.items. And rather than giving back to me something that looks like key colon value for each of these, what I get back is a tuple where the first item, the sub-0 item in each tuple, is the key, and the sub-1 item in each tuple is the value. I guess I have to do something. Okay, for x in d.items, let's print x. And of course, I can beautify this if I want by using subscripting. I can say for x in d.items, print key, comma. Now the key is x sub 0, and the value associated with that is going to be x sub 1. Okay, so remember that a key is a sequence. You can subscript into it, and you can get slices from it the same way that you can with a list. So x sub 0 is going to be the key. X sub 1 is going to be the value associated with that key. And so here's my result from that. And I can use other facilities in the print function, like the dot format method for a string, to beautify the output even further. Can anybody think of another way of making it convenient to separate the keys and the values when you're iterating through a dictionary? Yeah, go ahead. Oh, okay, when you're displaying things, you can use dot format. Exactly. Right. But I'm talking about, as opposed to doing x sub 0 to get the key, x sub 1 to get the value, do you remember what's called multiple assignment? I may not have told you about this. Maybe I didn't tell you about this. I'll tell you now. You can say in Python, a comma b comma c gets 1 comma hello comma none, And this is what's called a multiple assignment. Have we talked about this? So, okay, so this is cool. It's good to know. So the upshot of this single statement is that A gets set up to refer to 1, B gets created to refer to hello, and C gets created to refer to none. So if I print A and print B and print C, I get 1, hello, and none. Now, what's neat about this so-called multiple assignment is that if I have a tuple, do I have a tuple called? No, I don't. So let me create a tuple called T. All right, T here is a tuple. It contains 5 items. Okay, the first item is an int, the second item, I should say the sub-0 item is an int, the sub-1 item is an int, the sub-2 item is a stir, and what about the sub-3 item? All right, so the sub-3 item here is actually a set, and I can ask what is the type of T sub-3, and I'll get told, okay, that thing is a set. And then the sub-4 item is a Boolean value false. Now, I can say A, B, C, D, E gets T. I've got 5 variables on the left. I've got a tuple containing 5 items on the right. And this does what's called unpacking the sequence. T here is a sequence containing 5 items. And now I have those items independently. A, B, C, D, E. I really didn't show you this. I have to update my notes. Yes.
So the table A and B is numeric, is not a string, right?
Pardon me?
Is the table A and B is numeric, is not string, right?
Okay, excellent question. The type of A and B, in Python, we don't think of variables as having types like we do in almost all other languages that are out there, like in Java or C or C++ or C#. You would think of the variable as having a type associated with it. In Python, a variable name is associated with a value, and it's the value that has a type. So if I say type of A, what I'm really asking is, what is the type of thing that A refers to? All right, so at this point, A is referring to an int, but I can say A gets 12.34, and now the type of A, that is the type of the thing that A refers to, is a float. Did that make sense? Any other questions so far? All right, so what does all this multiple assignment have to do with anything? Well, we've got our dictionary D. No, we don't. I overwrote D, so I better go back and get D again. Okay. Here we go. I changed D to refer to a set instead of to the dictionary. So now I got to rebuild my dictionary name D. And we did this loop for x in D dot items. And we saw that what we get is tuples representing key value pairs. Now, because of what I've just shown you here, this idea of multiple assignment, another way I can say this is to say for k comma v in D dot items. I'm not required to use the variable names k and v, but to me they're meaningful. K for key, v for value. I could have called these, x and giraffe. You know, it doesn't matter what variable names I use. But this will separate the key from the value so that I can deal with them just by the names k and v instead of tuple sub 0 and tuple sub 1. Print key value v. Okay, so when people write loops to step through the items in a dictionary, you'll often see this trick used, so that the keys and the values are automatically in separate variables that you can just refer to directly, instead of using the sub 0 and the sub 1 subscript. Any questions? All right, well, now, I'm obviously not going to expect you to know this in terms of evaluating whether you know this, since I apparently didn't put it in the notes. But it is nevertheless a helpful thing to know. All right. So we have now looked at our 5 collection types, and we have seen that they are all iterable, and a dict is actually iterable in 4 different ways. You can iterate on the dict, which is the same as iterating on the keys, or you can iterate on the values, or you can iterate on the key value pairs, all the items. Okay? Now, of all these collection types, only the list is sortable. So given any list of values, you can say list name dot sort, and assuming that the values in that list are of some sortable data types, they will be sorted. Now, what do I mean by that? Let's see. So if I say, let me scoot this up a little bit. Here I have M, and if I try to say m.sort here, well, the list does have a sort method, but unfortunately I have a mixture of data types in this list. I have a string as well as 2 ints. The sort method understands how to put strings in order, and it understands how to put ints in order, but it doesn't know how to put a combination of ints and strings in order, so I'm going to get yelled at here. I get told that the less than operation is not supported between ints and strings. All right, so the key thing is that all of the items that are within the list, in order for the list to be able to be sorted, have to be comparable using a less than operator. All right, so if I say M1 gets a list, this is a test of list sorting. All right, so M1 is now a list of just strings. And the less than symbol is defined for strings. If I ask whether hello is less than howdy, that's true because in the ASCII character set, little he comes ahead of little ho. All right, so that's true. And so I can say m1.sort, and this is going to make sense. Okay? Now, we did, I think, I hope I'm not about to discover another thing I didn't tell you. We did talk about the idea of 0 being equivalent to false, right? And an empty string is being equivalent to false. So if I say things like if empty string print empty else print well, this is silly. All right, now I'm going to get the opposite output of what I should get, because an empty string, if you test whether it's equivalent to true or false, an empty string is actually equivalent to false. So I'm going to drop down here to the else part, and I'm going to print out that it's not empty. So I'm kind of upside down from what I wanted to do here as far as what's going to be displayed. But the point is that an empty string, if you use it in a Boolean test, is treated as false. The value 0 is treated as false. The value none is treated as false. The value 0.0 is treated as false. So anything that's empty or 0 is treated as false. In fact, I did mention that, did I not, when we talked about the if-else? Oh, no. Well, obviously, I'm not going to test you on that either. Okay. But what I'm trying to get at here is the idea that if I have a list containing 1, 4, 3.7, 9.9, false, true, that list has mixed data types in it, but I can sort it anyway, because false is considered, if you do a comparison of an integer, false is considered to be the same thing as 0. So false is less than 1. 1 is actually equal to true if you did arithmetic with these things. And then we've got 3.7, 4, 9.9. So the rule for whether you can sort a list is, can you compare all of the items in the list to each other using a less than test? If you can compare all of the items in the list using a less than test, then you can sort the list. If not, you can't. Yeah?
Just about this list specifically, true is equal to 1, I understand that. But does it always come, if you sort like this, does it always come after the actual integer one?
So I believe that this sort algorithm is what's called, yes, and what's the word I'm after? Stable. And so I believe that the reason that the 1 comes out ahead of the true is because the 1 appeared in the list ahead of the true in the original list. If I had said M3 gets list true 7, 1, minus 3, and said M3.sort, in this case, the true comes out ahead of the 1 because the true was ahead of the 1 there. Did I just do the? Yeah, no, that is the alternate case. Yeah. Yeah. If believe it or not, you can do arithmetic with Booleans. You can say true plus true plus true and get 3. Okay, again, I'm not gonna evaluate you on that. But what I was trying to do here was to show that you can sort lists. You can't sort these other collection types. With lists, there's a restriction that you have to be able to do a less than comparison among all of the various items in the list. So all strings is fine, all numbers and Booleans is fine, but some mixture of strings and numeric types and Boolean types is going to fail. Good. Okay. All right, and so here are more examples that I'm not sure that these are really worth looking at. You can try them out. Well, let me do a few of these anyway, since I bothered to write them down. So if I say stir1 gets this, stir1 is a string, and I claim that I claim that st1 is immutable. However, I am able to do things like this: st1 plus gets and that. And for some reason, I didn't get complained at. So what's that about? Well, the plus gets operator is interpreted as st1 gets st1 plus some string. So in this case, the plus gets is really just an abbreviation for assignment and addition. And addition of strings is what? It's concatenation, right? And it's perfectly fine to compute this plus and that. What that does is to create a new string, this space and space that. And then what I'm doing is I'm simply modifying st1 so that st1 refers to this new string, this and that, rather than to the original string it referred to, which was just this. All right, and so down here again, if I say st1 gets st1 plus space and another, well, the current value of st1 is this and that. I'm going to append the stir and another. That resulting stir is then going to be referred to by st1. So I'm just building a string in memory, and then I'm making my variable st1 refer to that string instead of the string that it was originally referring to. Okay, so you might be tricked into thinking that this is doing a mutation of str1, but it's not really. It's just changing str1 to point to a different string, to refer to a different string. And I already showed you an example of trying to use a subscript, and we get yelled at in that case. Okay. Now, when you iterate through a string, what you get is the one-character substrings. Okay, so st1 is now pointing to this and that and another, and when I iterate through that, as we know, we get the one-character substrings out of it. And what I'm doing here with this print function is printing them on the same line. I'm ending each line with a space character. I have shown you end and sep, correct? Good. Good. All right. Here we have examples of involving lists. I think we've kind of beaten lists to death. Is there anything on here that you'd like me to do, or are we good? Okay. Now, here we're creating a tuple of one item. Tup1 is just 7, and the comma is required in order for that thing to be a tuple. I can apparently modify tup1 by using plus gets, but that's an illusion. It's sleight of hand, because what I'm really doing is the same thing that we did with strings. I'm really saying tup1 gets tup1 plus some other tuple. Plus here is going to concatenate these tuples, and then tup1, the variable tup1, is going to be changed to refer to that new tuple instead of the tuple that it originally referred to. All right, so it appears perhaps that I'm modifying my tuple, but I'm not really. I'm modifying my variable to refer to a different tuple. And I cannot assign a value to an item in the tuple because it's not mutable. Okay, sets. Now, a set is mutable. Set 1. I can say st1.add 8 to add an element to the set. I'm not allowed to say st1 plus gets 4, 7, 10. In my mind, that might make sense. The plus gets might imply to me, well, I'm really just wanting to add those values into the set, and that's fine. But Python doesn't support plus gets for sets and sets. So in order to get what I want there, I need to say st1 gets st1.union, and with union I can specify this set as the iterable that I want to add into my set st1. And so now st1 is the union of what it originally was with 4, 7, and 10. Okay, so 4 was already in there, so I really just got 7 and 10 added. Good. All right, so we've seen how to create empty items, empty collections, single item collections, multiple item collections, and we've taken a look at which ones are iterable, which ones are sortable. Now, which of these can we get slices from? Which of these can we delete values from? Well, you can get slices from what are called the sequence types. And in our collection of 5 that were, our collection of 5 collections, in our group of 5 collections that we're talking about, the stir, list, and tuple are all considered to be sequences. That means that we can get slices from them. It also means that we can use square brackets with integer subscripts starting from 0. So sub 0, sub 1, sub 2 is meaningful for these guys. We can't get slices from sets or dicts. In the set case, it's because there's no concept of order for a set. So asking for the sub-0 item up through and not including the sub-4 item, there is no sub-0 item, there is no sub-4 item, so that doesn't even conceptually make sense. For dictionaries, we can't do it because integer subscripts are not are not in most cases used as keys. Okay, we can have strings for keys, we can have booleans for keys, we can have for that matter, we can have tuples for keys. So there's no concept of slicing a dictionary either. We can delete values from lists, sets, and dictionaries, but not from the 2 immutable things, strings and tuples. Now, the mechanism that we use for deleting things from lists, sets, and tuples are quite different from each other, but we are allowed to do it. Okay, so here we're showing a slice of a string. If str1 refers to, really this is a test, I can modify str1 to refer to a copy of its original value just starting from item sub 1 to the end. So what that does is to cut off the R at the beginning. Obviously, we've been doing that by using :-1 to get rid of the new line at the end of input lines from files. I can get slices out of lists. To delete stuff from a list, it turns out you can delete a slice. And I don't recall whether we've talked about this or not. So let's take a look at M3. All right, so M2. So here's M2. M2 sub 1:3. Sorry, 1:3 is the slice from item sub 1 up to but not including item sub 3. So it's the slice of these two items, 1 and true, correct? You can delete an individual item from a list by using its subscript. Let me say -1. I don't want to count with my finger how long that list is. I just know I want to eliminate the last item. So I'll say delete M2 sub -1, and sure enough, the last item from M2 is gone. Or I can say delete a slice, M2 sub 1:3. Whoops. And the 1 and the true are now gone from the list M2. Okay? Now, deleting things from... I was sure I had examples here, so I will make examples up. Deleting things from sets and tuples is quite different. If I say, here's my st1. If I say delete st1 sub 3, well, that's not going to work because there is no sub 3 item in set 1. Yeah?
Can you explain why there's no dot between del and delete in that command? Many of them do have, and this one does not.
Very good, very good. Excellent question. Excellent question. A method that operates on an object is always going to be executed by saying object dot method. And usually the method is a function that takes arguments. So that is always how you execute a method that is associated with a particular kind of object. But del, it turns out, is not built into the data type itself. Del is a top-level command within Python that simply deletes a particular object from memory. And so you can use del in a variety of different ways. I have a variable called a that refers to the float value 12.34. If I say delete a, well, that variable is gone now, and therefore the value that that variable refers to, unless I had some other occurrence of 12.34 in my program, that variable that it refers to can be released from memory. Okay, so a no longer exists. If I have a list M3, I can say delete the particular object M3 sub 3. Okay, that's going to be this object 7. And so that object is going to be deleted from my list. Or I can say delete M3 sub 0:1. Okay, now 0:1, that's a slice, but it's a slice of just one item. It means all the items from sub 0 up to but not including sub 1. So it's treating item sub 0 as a slice, which is legal. And so the -3 has now been deleted from the beginning of that list. Or I can say delete M3. And that will delete the variable M3, and therefore the list that M3 referred to is able to be deallocated from memory. Okay, so del is not a method that's internal to these data types. It's a top-level facility that you use to eliminate objects. Now, I can't say, here's my st1, I can't say delete st1 sub 3 because subscripting doesn't have any meaning on st1. Subscripting doesn't have any meaning for a set, so I get yelled at. But I can say delete st1. And that deletes the whole set. The whole set is now gone. That variable no longer exists. And because the variable no longer exists, that collection of values can be released from memory so that the space can be reused for some other purpose. Did that help?
Yeah, thank you.
Any other questions so far? Okay, so let's get back to deleting. We're talking about deleting things from these collections. And I've shown you that if I have a list, I can delete individual items using a subscript. I can delete sets or sequences of items. Well, let's just see what the change was. So M1 sub 3 is actually of, so of is now gone. I can delete slices. All right, so let's see. So 4 and 5 up to but not including 6. So test this should be gone now. And I can delete the entire list. Okay? Now, where tuples are concerned, I can't delete individual items or slices of items because a tuple is immutable. So if I say del t sub 0, I get yelled at. Or if I say del of t sub 2:4, I get yelled at. But I can certainly delete the entire tuple. And now t just no longer exists. For sets, okay, I guess I deleted it already. That's right. So st1 gets, let me just put some numbers in here, 4, 1, 3, 7, 8, 3, 6, 1. All right, so I've defined a set by putting a sequence of values in curly braces. I intentionally put in a couple of duplicates, but the duplicates are going to be eliminated, so I'll only have 1 3 and I'll only have 1 1. And I cannot say del st1 sub 0 because there is no subscript operator on sets. I can delete the entire set. Okay, so if I want to get rid of the entire set, I can do that. But if I want to delete individual values within the set, now I have to use methods. So I can say s1 dot discard 4. And that eliminated that particular value. I can try to discard a 9, and discard is friendly. It doesn't yell at me, but it also doesn't do anything in that case. Whereas if I say st1 dot remove 3, that removes the 3. And if I say st1 dot remove 9, 9 is unfriendly and raises an exception if I try to remove something from a set that doesn't exist. So I can use either discard or remove to eliminate individual values. How could I get rid of all the values at once but still leave the set existing? Any recollection? Clear, good. Yeah, so st1 currently contains 4 items. If I say st1.clear, that eliminates all of the items, but the set still exists. And notice how the empty set is represented as the conversion function set with empty parentheses. Okay, this is very different from saying del st1, which eliminates the variable st1 completely. All right, so there's a difference between having an empty set and not having a set. Good? All right, and then for dictionaries, let's see. Yeah, I still have a dictionary sitting around here. I can use delete with a dictionary if I give a key as a subscript. Okay, I don't have any concept of sequences with dictionaries, but I do have subscripting, if you will, or key lookup using the square bracket notation. And I can use del to eliminate items from the dictionary. So D no longer has an item with a key of A. I can wipe out all of the items in the dictionary by saying clear, but I still have an empty dictionary. I can get rid of the dictionary itself and everything it contains by saying del D. Okay, so we've taken a look at these 5 different collection types. We've seen how we can create them as empty, or as having one item, or as having multiple items. We've talked about how we can access items within these classes using subscripts in the case of the sequences. Okay, so stir and list and tuple are sequences, and so I can use the square brackets with an integer value, 0 through whatever, to access those items. Those sequence types are also sliceable, so I can use slices to access slices of items from those. And then to access particular values in a set or dictionary, actually, let me put my set back again. We didn't talk about accessing particular items in a set. Okay, how can I access a particular item in the set? What do we even mean by accessing a particular item in a set? In the case of a set, when we're talking about accessing an item, what we're really talking about is we want to know, is the item in there or not? And how do we find out whether an item is in the set or not? Sorry? I hear people saying it. I just can't quite hear loudly enough. In, exactly. So I can test whether 5 is in ST1. I can test whether 6 is in ST1. Sorry. I must have hit the F1 key by accident. And then for dictionaries, of course, I've wiped out my dictionary here, but let me just create one really quickly. D gets 5, 4, or 5:4, 6: high. The way I can access items in the dictionary is to say D sub, and then give a key that exists. And if I try to access an item that doesn't exist, or a key that doesn't exist, I get a key error exception raised. All right, so accessing items, removing items, we've now talked about all those good things. Any questions? Okay. Okay, so these are yet more examples for lists and for tuples. All right, so we also, now that we know about these 5 different collection types, we want to take a look at these conversion operations a little more. It turns out that you can use these conversion operations to convert one kind of iterable into another kind of iterable. For example, range, we know, if I were to say for I in range 5, print I, comma, and equals space. If we use range with 5 as our only argument, we're going to get the integer values 0, 1 through 3, 4. Okay? Now, list will convert that range iterable into a list. Set will convert that range iterable into a set. Tuple will convert that range iterable into a tuple, and so on. So given some iterable, which can be something like range, or it can be a string or a list or a tuple or a set, given some iterable, you can immediately build these other collection types from those iterables. If for example I say, let's see, str1 is hello world, this is a test. Well, we know that a string is an iterable, so I can easily get a list of all those one-character strings by saying, give me a list from the string, or give me a set from the string, or give me a tuple from the string. Okay, so these conversion functions, stir, list, set, tuple, allow you to build strings, lists, sets, and tuples from any other kind of iterable. So you can build a string, you can build a list from a string or a list or a tuple or a set or a range. For that matter, you can build a list directly from a dictionary. Let's look at this one. So D is my trivial dictionary here. Let me also add D sub 9 is none, just for gags. So D now has 3 items in it. And if I say MD gets list D, what would you expect to have happen? D is an iterable, a dictionary is iterable, and what do you get from accessing a dictionary as an iterable by default? If I were using a for loop to step through D, what would I get? I'd get just the keys, right? I get the keys by default. So, in other words, let's see, TD is tuple from D.keys. D.keys is another iterable that explicitly gives me the keys. All right, so it turns out if I just use D as an iterable, it's the same as if I use D.keys as my iterable. So now I have a tuple from the dictionary's keys. Let's say SD gets set D.values. All right, so D.values is the iterable that gives me the values, and now SD is a set of those values, for, none, and high. Now, I want to point out something cool here, which is what I was hoping that we would see. When I created a tuple from the keys, I said that in Python 3.7, the items in a dictionary are stored in the order of key creation. So the keys are created in order 5, and then 6, and then 9. So when I created a tuple from the keys, the tuple contains 5, 6, and 9. values, I claimed, would come out in the same order. So the value should come out as 4, high, and none. But do I have 4, 9, and I'm sorry. The values are 4, 4, high, and none. Does the set contain that order of values, 4, high, and none? No. Well, remember, a set isn't ordered anyway. So when the set got built, 4, high, and none were put into the set, but then the set, for whatever reason, decided it was going to represent them in a different order. Okay, so this is not a mistake here. It's just an artifact of the behavior of sets, which is that sets store things not in any particular order. Okay. All right, so I've shown some examples of dicts. Oh, I did want to mention that that in a dictionary, and we talked about this pretty close to the beginning of the class, the keys do have to be hashable. You can use stir, int, float, a Boolean value, or none as keys. Those are fine. You can also use a tuple as a key as long as the tuple doesn't contain something like a list or a set. If the tuple contains a list, then the tuple is not hashable because the list within the tuple can change. Is that something we've talked about? I think I talked about this. Here's t. If I say t gets t plus, all right, t gets t plus. Now I'm adding, I'm appending to my tuple containing 0, 1, 2, 3, 4, a tuple containing a list, 4, 5, 6, and a set, 6, 7, 8. So t now contains 4 ints, a list, and a set. And so if I now try to say set 5 gets a set built from t, I'm going to get yelled at. We have an unhashable type, a list, as one of the items within the tuple. And I think I did do this song and dance when we talked about tuples. If I say t sub, let's see, which item in here is the list? T sub what? T sub 5, right? T sub 5 is my list. I can say t sub 5. Well, let me first do this. Let me first look at the ID for my tuple. Okay, so the variable t refers to the object that has that ID. If I say t sub 5 dot append 9, all right, I claim that a tuple is not mutable. Oh. But the item within the tuple, if it's mutable, can be modified. The ID of t here is the same. So the original ID for t was blah blah 808, and the ID now for t is blah blah 808. So the ID hasn't changed. It's still the same tuple. From Python's perspective, the tuple has not been altered. What has been altered is the list that exists as one of the items within the tuple. So this concept is a little squirrely, that you can change a mutable item within a tuple, and Python doesn't consider that to be the same as changing the tuple. But you cannot use a tuple containing a list or a tuple containing a set as a key in a dictionary. That's the bottom line here. Okay. We've talked about various of these functions. Oh, I know why this stuff is in here. Okay, we went through all of this dictionary stuff last Thursday, correct? I mean, we've gone through all of these dictionary slides. I think the last time I taught this course, we didn't have time to get to that stuff, and so I appended that to the material for today. But fortunately, we're out of time, so we don't have time to talk about it a second time anyway. Let me see if there's anything else in here that I need to add. Did we talk about zip last week? I think we did.
I don't know if we did.
Okay, so let me tell you about zip. So zip is cool. Here, let me create. Let me see. I have. All right. So T has 7 items in it. 5 ints, a list, and a set. And S has. Oh, S is a set of 5 items. ST1. No. STR1. There. STR1. Okay, if I say zip 2 iterables together, 1, 2, 4, 7, and help. If I zip 2 iterables together, what I get is an iterable on tuples where the first item in the tuple is an item from the first iterable. So in this case, the first item in the tuple would be the first item in the first tuple would be 1, and the second item in the tuple is the first item from the other iterable, which is h. So I'm going to get 1h, 2e, 4l, 7p from this zip. Except that zip doesn't show that to me unless I ask to see it using something like for loop. So for x in zip this stuff, print x. Okay, so as I said, zip is going to zip these 2 iterables together into tuples of 2 items. The first tuple is going to be 1h, the second tuple is going to be 2e, the third tuple will be 4l, and the fourth tuple will be 7p. From that, we can create a dictionary. So I can say D2, okay, I don't have anything called D2. D2 gets dict from this zip object. In other words, well, let me do this and then say what in other words is. All right, so I've created D2 as a dictionary. 1 is the key for H, 2 is the key for E, 4 is the key for L. This is sort of the inverse, if you will, of saying something like for X in D2.items, print X. Just as the items iterable gives you back a sequence of 2 tuples, all right, where each 2 tuple has a key and a value in it, constructing a dictionary using the dict conversion function operates on an iterable on 2 tuples. And so that's what zip gave me here. Zip gave me an iterable on 2 tuples from which I was able to construct this dictionary. Let me create a dictionary based on an iterable of 2 tuples that's much more direct. If I say D4 gets dictionary, let me create a list of 2 tuples, 5 comma high, 6 comma go, 9 comma fish, 12, comma, pi. I had a thread there, but I don't know what pi has to do with going fishing. Okay, so I'm using my dict construction function to build a dictionary. And what I have here to build the dictionary from is a list of two tuples. So the first item in the dictionary is going to have a key 5 with a value of high. The second item will be the key 6 with a value of go. Then the key 9 with the value fish, and the key 12 with the value pi. Okay. Okay, so that's an example of how to use the dict conversion function to take some sequence of two tuples and build a dictionary from that sequence. The sequence can be a list. It could have been a tuple. I could have had a tuple of two tuples. Or it could have been a zip object. Okay, zip takes two separate iterables and zips those together into an iterable on two tuples. And so those are examples of how to build a dictionary from other values. And now I'm 1 minute over. Okay, so we'll call it quits there. I hope that enhanced or deepened some of your understanding about how these collection things can be used together. Using iterables, using for loops, using conversion functions, and so on. If you do have any other questions about anything, as usual, fire me an email, and I'll respond. Okay, so Thursday we will have the quiz during the last half hour of the period.